Yeah, students, good morning to all of you. So till yesterday, we were discussing numerical problems. Now we are coming to a new lesson. This is uniform circular motion. Uniform circular motion we have already discussed in the topic two-dimensional motion, because uniform circular motion is an example of two-dimensional motion also, right? That means projectile motion we have seen two-dimensional motion. In the last, we have discussed the uniform circular motion. And also we have discussed the centripetal acceleration also. Centripetal acceleration is given by centripetal acceleration. Acceleration is equal to many formulae we have done. That means one is called V omega, second is called R omega square, and third is equal to V square by R. Many formula we have seen. So you will see that video also. It is in your ownership now. All these videos you can see. So uniform circular motion means that also you understood. I think you understood. A body moves in a circular path with a uniform speed. That means constant speed when a body moves in a circular path. This is an example of uniform circular motion. Right? Then centripetal force. Centripetal acceleration. Centripetal acceleration, you know, that is mv square by r, or v omega, or r omega square. So when acceleration we have centripetal force can be calculated. Therefore, centripetal force is equal to what? Acceleration once again I am writing v omega, r omega square, and also v square by r. These are all the expressions for same only, but in three different forms we will use it for purposes, right? So when acceleration we have centripetal force also can be obtained. Centripetal, but force is equal mass into acceleration. Therefore, mass into acceleration means one. Centripetal force, centripetal force. CPF I am writing here. Centripetal force is equal to mass into, that means mv omega we can write. One. That is equal to mr omega square we can write. Mr omega square we can write. That's equal to m into v square by r we can. All these formula are lavishly used in doing problems and all. Right? mv omega, mr omega square, mv square by r. This is what is centripetal force. So when a body is moving in a circular path, always there is a force acting on the body, because the direction of the body is changing because of the force. So the force is always changing trying to change the direction of suppose this is the path of a body which is moving in a circular path, right? At any instant, suppose the body is at P, at some other instant the body will be at Q, at some other instant the body will be at R, and some other instant the body will be at S, and quantities going on moving in the circular path. Remember that its speed is always a constant. Speed of a body, the direction of speed of a body is always represented by a tangent placed at that particular point. So suppose this is V. This is speed I am talking about, right? Here the speed is this one, this is V. And here the speed is like this, here the speed is like this. So when body moves in a circular path, its velocity or speed is always along the tangent placed at that point. Okay, right. The magnitude of this velocity, suppose if it is velocity, if I speed, this is all velocity. Velocity means that is always represented by a tangent placed at that point, at those points. At P, this is an tangent, at Q, this is, but all this velocity direction are always changing. But remember, its magnitude is what is called speed. Speed is always a constant, right? So this is what is called uniform circular motion. In uniform circular motion, there is a force acting on the body towards the center. That is why its direction is always changing. And this force is given by one is mv square by r, that is mr omega square, that is mv omega, all this. The centripetal force is always acting on the body toward the center of the circular path. That's why it is called a centripetal force, right? There are several examples we can cite for circular motion like this. Every circular motion, the centripetal force is acting on the body toward the center of the circular path, right? The best example is that our Earth, Mother Earth, is moving around the Sun in a circular orbit. Always there is a force acting on the Earth toward the Sun, and this is what is called a centripetal force. Because of that force only, the Earth is always in the same path, same circular path, intact. Right from the beginning date to this date, beginning of the universe to this date, the Earth is moving in the same circular path because of the centripetal force, right? Velocity of a body which is moving in a circular path is always along the tangent at that particular point. In a uniform circular motion, the modulus of velocity always remains a constant. If this modulus of velocity v is equal to 5 meter per second, this also 5 meter per second, this also 5 meter per second, this also 5 meter per second. But the speed is same, but velocity is different. Remember that. Speed is same, but velocity is different. Why velocity is different? Because velocity is changing its direction. Why velocity changes direction? Because always there is a force acting on the body. So at every moment, the force is toward the center. Therefore, the body is pulled toward the center with a force. That is why it is changing its velocity direction. So this is an accelerated. All circular motions are examples of accelerated motion. That acceleration is called a centripetal acceleration. There are many examples of centripetal force we can cite. Suppose a stone is tied to one end of a string and it is rotated. And it is rotated, you will see that you have to apply a force there. When it is moving like this, you feel that there is a force is acting at your two fingers that are holding the string, and that is what is called centripetal force. Understand? If the string breaks, you will see that the stone moves along the tangent to the circle. Remember why? Because any body moving in a circular path, its velocity is along the tangent only. Same thing you can see that suppose that in your cycle in the rainy day, if when you are moving in you are cycling in a road, the dirty water and mud etc. are moving in a tangential path from the tire of your cycle, because that has no control toward the center. That means these particles are free to move. But when the wheel moves, these particles are also free to move. But as this particle has no control toward the center, they move in the tangential path. That is the actual directional velocity of a body which is moving in a circular path. Right? In a cream separator also, you can see that suppose the milk is put in a cream separator, and the cream separator is that machine is rotated in a very high speed. Then you will see that the heavy particles having more force that will be moving toward the periphery of the circle, while the lighter particles, what's called butter particles, that will be collected at the center. Right? In that way, we can separate cream from milk. This is called as cream separator. Heavy particles of having very high mass will go away from the center of the path, while lighter particles will be remaining at the center of the circular path. Right? Okay. Then centrifugal dryer also, as in wash machines and all, you have seen centrifugal machines. Centrifugal dryer it is called. That the centrifugal dryer has so many holes in it. Wet clothes are put in, and it is made it rotate in a very high speed. And this when the clothes that will be going around in a circular path, that will be in the periphery of the circular path, right? The water particles, they have no control toward the center. That will be separated and will pass out through the small holes made in the centrifugal jar. So these are all best examples of centripetal force. Centripetal force, when acts on a body, there is a centrifugal force also. It is not a counter reactionary force, but it is only a imaginary force. So it is observed that the particles, when they move in a circular path, there is a force acting away from the circular path. Actually, the existence of this force cannot be established. That is why it is taken as a eccentric. It is taken as a what is called a fictitious force, right? Because it cannot be proved, and there is a force acting on the body away from the circular path, right? But it can be experienced most of the time when you sit in a merry-go-round. Also, you can feel that you have a feeling to that you will go out of the circular path. That is why you will hold the other side of the cabin in which you are sitting. Thereby you will get a reactionary force. That reactionary force will provide you necessary centripetal force that you can move in a circular path in a merry-go-round very safely, right? Another examples of circular motion of a car in a level road. What we are going to discuss today. Motion of a car in a level road. So the figure is shown here. So all these things I said, and you will follow this again and again, seeing the video, right? Okay, this is a very simple thing. A car is drawn here, right? It is moving in a circular path shown in the figure. It is a level road. On a level road, you will see that the weight of the car is acting downwards on the floor, and the floor will act a force in the upward direction that is called reaction, force of reaction. These two are cancelling forces. Cancelling forces means due to the effect of mg, the car is not going down into the road, right? Due to the action of the reaction force, it is not flying up in the air. Therefore, they are cancelling forces, right? When the body moves in the circular path like this, centrifugal force, that means that has a tendency to move in the outward direction, right? In the outward direction, it has a tendency to move. Therefore, the force of friction is in the reverse direction. So the car has a tendency to move, as I told you just now, centrifugal force is there, but it is only experienced, but it's a reality cannot be established, right? So car has a tendency to skid away from the circular path. So skidding direction is away from the circular path. Therefore, the force of friction is in the opposite direction. Force of friction is acting toward the center